Look at how to create a web server. And so just at a really basic level, listen and serve when you're using the Go language. And then you can put in the address, :8080. Normally this would be port 80 on the web when you're in production, but in development we just use 8080, which is a high-level port not used for anything. So it's nodding to the fact that this goes to port 80, TCP port 80. And it's going to use default servmux. And then I do HTTP handle func. And like all of this stuff, I'm not going to walk through the documentation because the class I'm giving this presentation to is just an introductory computer concepts class. But I'm just kind of giving a flavor of what it takes to program the web today. But if you're out there on the web watching this on YouTube, first thing you want to do is follow me on Twitter. Because I'm always tweeting about cool stuff, Go programming language and web development. So that's how you find me on Twitter. And the other thing is on PayPal, send me some money. Just kidding. That was a joke. So I'm not going to go through all the details, but this is where we look for the Go programming language to read the documentation about these different functions I'm using. And so there's listen and serve. I'm going to listen on that port. And then I do handle func, and I say anything coming at this route, I'm going to have it run this function foo. And then that function foo has to conform to a certain setup, because everything on the web has a request and a response. And so there's the request and the response, and then I'm just going to write back. And I could do this in a variety of different ways. I just need something that takes a writer. I'm going to write back you are at foo. And then if I wanted to, I could add in dog. And then I could say anything coming here. Actually, I'll add in bar, right? And then I'll just do another function and call it bar. Interesting? And then you are at bar. And so now I could run this, and I have to launch my terminal to do that. And terminal is a command line interface versus a graphical user interface. And I'm going to go change directories into Golang Web Dev. So most of us navigate our computer these days with a graphical user interface, but this is how we did it in old days. And then once I'm in there, I'm going to go into the temp folder and 37, and then I'm going to say run this program. And so that's now running, and if I come to my web browser, you are at foo. And if I go to dog, you are at bar. Like I've created a web server, and that's responding. And I've written back text, but all I need to do right now is write back HTML. And I'm sending web pages. So in the spring, I'm teaching the HTML CSS class. And this class for web programming with Go, server-side technology. So you can learn both of it. And if you wanted to get going early on it, you could find me on Udemy. And you can learn. This course is just launched, so you could only find it right here. It's in the pre-approval process. You can only find it under my account. But you could take the HTML CSS course, and you can learn that programming. This is a nice programming course. It's low-key. It's me after looking incredibly tired after my kids have gone to bed in the garage, recording these trainings. All right, so you can check that out and get going on it. So that's just like the start. Well, what's happening behind the scenes, is that we have some things happening at the TCP level. And how many people are still interested, or you've seen enough? Like, oh, I'm still kind of interested to see a little bit more. Raise your hand. And how many people are like, I've seen enough? Seen enough? Cool.
That website was Udemy?
Udemy, yeah, U-D-E-M-Y. And so the first battle you face as a web programmer or as a business person is choosing the appropriate implementation of technology. So if you're watching this video online, we are going to do the TCP thing. Just hang out a second, right? And so what's that mean, choosing the appropriate implementation of technology? You want a website. It's kind of like saying you want a car. And if you want a car, you could go out and you could get a BMW with very fine German engineering. Or you could go out and get a Daewoo or something made in China, which falls apart quickly. I don't know. I just made that car company up. What's a really bad Hyundai, right? Or what's the other one? The one that's the Italian Fiat. Fiat doesn't necessarily have the best reputation traditionally. I don't know how the reputation is now, right? But you could buy the wrong technology. And so just the same thing, you could like build a website with PHP or ASP. Wrong choice today. Or somebody might sell you on Ruby, because that's what they know, the developer. Wrong choice today. Or somebody might then sell you on Python or Node. Wrong choice. Closer to good, but not quite there by a long measure. And the right choice is this language here. It's Go. Why is it Go? I've told you before, right? Because of Go's credentials. Google is rewriting their entire infrastructure in Go. What else do you need to know? Google created the language. What are the first two letters of Google? Go. Right? Google created the language because none of the other languages were doing what they wanted them to do. They said we have to build our own. And they enlisted the best people in the world to build it. Some of the same people who helped create Unix, UTF-8, and the C programming language. Whoa. So this is Go. And it reads really easy. And once you understand what all the different functions are, okay, cool, that's not too complicated, right? You know, it takes a little bit of time to get into the language, but you can learn it easily. So I'm going to save this as just like, example 1 and drop this file in it. And I'm going to copy that file and put it in 02. And then in here, we're just going to try to do something at a little bit of a lower level. So if we were to inspect listen and serve, go look at it, we would see, okay, listen and serve calls a server, and that server calls listen and serve, and that's maybe a little bit different. It returns listen and serve. So we could dig around in here, and we see net listen, and that gives a listener. And then we could see, okay, serve, listen, TCP listener to keep active listening. What's serve do? And it defers the listener's close, right? And there's the listener. And then it accepts incoming connections. And then we get, things happening here. And, and then it goes and it serves it. And when it comes and serves it, context, okay, so some pretty interesting stuff. But the net package, if we look at the net package, that's one of the things that stood out. And we go and look at the net package, we see a lot of things happening with TCP. And TCP and UDP are kind of that layer of the OSI model, which I've shown you, that's right below HTTP. So TCP is really what serves HTTP pages. TCP is just, HTTP is on top of TCP, and HTTP is just a protocol for how the text being sent back and forth should be formatted. It's that protocol right there, which I drew on the board. This one, not right there, but this one right here, which is kind of the same thing, where we have the start line, the headers, and then the body. The start line, the headers, and then the body. It's not shown here, but that's called the request line. The start line is called the request line in a request, and it's called the status line in the response. Just checking those out. So let's strip that out and let's just play with it a little bit. So I could get a listener, and it returns an error. And from the net package, I'm going to listen, and it asks for a network and a listening address, right, which is a string. They're both strings. So I'm going to pass in the network is going to be TCP, and the listener will be :8080. And then I get that error, and I check the error, and I say log fatal, right? If this thing doesn't work, then our program's done, and I can just log the error. I'm going to defer the close of that. So in programming, when you open something, or on your computer in general, but also in programming, you got to close it. If I was on my browser and I kept opening tabs, that's going to take up memory, right? Like I just opened a whole lot of tabs. And I want to close those when I'm done. And then that saves memory. That was pretty cool, wasn't it? So I've got my listener. And now I want to do some listening, and I want to accept. And so I could do an eternal for loop, and I'm always going to be running this. And I want to do listen accept. And accept is going to returns a connection and an error, right? So accept runs, and it returns a connection and an error. So I get my connection, and I check my error. And then check my error, and log, just print line this time, because I might have some error that, I don't want to close the whole program, but I'll just, log what that error was. And then I want to defer the close of this connection. And so I've accepted a connection, and now I have a connection. Well, what is a connection? If I go and I look at what a connection is, I can see a connection is an interface that you can read and write to. Cool. So I can read and write to my connection. So I've got my connection, and I could do C, and I could see all of the different things which are available for the connection. Close it, write, read, write deadline, right? But because a connection has a writer and a reader, right, the write method and the read method, it's a write interface and a read interface, I could do this, IO write string. And what am I going to write to? I'm going to write to my connection. I'm going to say something. Hello from our TCP server. Now I'm going to run it. That's running. I launch a new tab. So I create a new tab in my editor. And I go to telnet localhost 8080, because that's what I said. Telnet allows you to call in on the TCP network. So we called in, and it responded, hello from our TCP server. That's pretty cool. I'm going to shut that down. So we called in, this accepted the connection, right? There's the connection, and then here we were able to write to the connection. Can we read from the connection? Like if we were to send it data instead of connecting and then receiving data like we just did with Telnet, and so our server wrote to the connection and our Telnet received it, can we write to the connection, right? Like when we call in, whoever's the client is calling in and they send information. That's what a browser does. What's it send on the request? Sends this formatted text, which is a request line, the start line, headers, and any body, right? So let's see if we could change our TCP server. If I could ever get my finger motion to bring me back to that menu again. Thank you. I'm just like sitting there pawing my thing. So I'm just going to save this as an example and make a new one, 03. And now we're in 03, and I want to read from the connection. And it takes a reader. So I need something that could read from the connection and then just print that out in my terminal. And so I could say ioutil.readAll, and that takes a reader. So I'm going to pass in my connection. And what does that return? It returns a slice of bytes and an error. So it gave me back a byte slice and an error, colon equal. And I can check my error. And log, print line, error. And then funct, print line. And I'm going to print my string, turn it to a string, my byte slice. So I turn my byte slice into a string and I print that to my terminal. So anything that comes down the connection, I'm reading it. I'm reading all of it. And if there's an error, I just say, oh, there's an error, and I print that out to my terminal, my log, whatever I've set that as. And then I get that byte slice, I turn it into a string, and I print it. Let's run this one, and I have an idea. Hopefully it's going to play out. Imported, not used, I/O. Get rid of that. Localhost 8080, kapow. Look at what happened. Ladies and gentlemen, we are looking at RFC 7230 from the IETF. Request for comment 7230 from the Internet Engineering Task Force. Here we have our start line, which for the request is called the request line. It's got the method, the URL, and the version. Right? So the method space URL, URI. A URL is the URI plus the URN. Uniform Resource Identifier plus Uniform Resource Name is the URL. Generally speaking, you could say URI or URL. Uniform Resource Identifier, Uniform Resource Locator, close enough, same thing. It's got the method, a space, the URL, the space, and an HTTP version. And then here are all of the headers. These are the headers. So cool, right? And now we could like start doing stuff. And so some of the stuff we could start to do is we could start to do some of our own routing and creating our own servmucks. We saw how there's that abstracted code which did the routing for us. We used HTTP listen and serve and HTTP handle func. And we said, oh, this route run this code, this route run that code, right? And we had foo and we had bar. So we went to one route, default route, it ran foo, right? We went to another route. Let me just toggle your memory. Right? Whoa, bouncing all over. So we went to one route, we went to foo, so this code ran. Another route at our browser, we went to bar, and so this code ran, right? And listen and serve is our server that's listening. We can now start to build up our own TCP server, right? Because we, instead of just reading everything, we could say, okay, what is the method and what is the route? And based upon that method and that route, we could do certain functionality. So I can see this is getting a little bit involved for some of the people, right? Not necessarily the intent of this class, but I thought it'd be interesting for you to get a flavor of what programming is like. And I'm not going to leave you hanging if you're watching this online, because you could scroll to this code base, which is at GitHub, goes to 11, Golang Web Dev, right here. And then in that code base, if you go down to understanding TCP servers, building a TCP server for HTTP, I've built out this entire example, right, where we listen, we get our listener, we defer its close, we do this eternal loop, we accept any connection that comes in, and then I have another function here called handle, right, which passes that connection into here, and that's a go routine, which means it can handle as many connections as you want to throw at it, so long as you got the hardware to take it. So that's concurrency, that's concurrent programming, which may or may not result in parallelism. It's concurrency as a pattern. Parallelism is the implementation where it hits multiple CPUs and is running on multiple CPUs. But if you're running this on a machine with one core, you do not have parallelism. You have concurrency, you don't have parallelism. So here we handle that, and we get a request and a response. We pass that connection in to read and write. For the request coming in, we use buff.io new scanner, give it the connection. Right? That gives us back a scanner. We do a for loop to loop over all of the tokens in the scanner. We say give us the text of each token. We get that line. And if this is, we have a little flag here. If it's the first time through, the text that came in when we're listening, first time through, we're getting this line of text. So we're going to take that line of text and we're going to do strings fields and give me the first item in that line of text, which is going to be the method get. So I assign that to m, right? That's the method, and there's the method. And if the line is equal to nothing, break, because that means there's an empty line after the header. So we're done with this part. So what that results in, I thought the result was all right there, right, is the request, scan, print the line, I equals 0. I'm in the headers. I pass that into my mux. And then in my headers, I get what's in position 0 and position 1. So I get the method, I get the route, the URL, the URI. So now I could say, hey, if it's get and this route, run this code. And just call that function. Or if it's get and it's this route, run apply at this connection. Or if it's post and this route, run apply process. And then I have all this code down here. Each of those functions that are called right there are all down below. And so this is what you get when you build all that up from the TCP level. And that's 0.16.05. Bum 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 bum. We have just created our own web server at the TCP level. And I could click on the different pages, and you could see this changing. I'm going to the different pages. I go to apply, and I apply, and it processes my request. Obviously, I didn't do any fields, form fields filled out there. But that is the shit. I don't know any other phrase that captures it, but like you just coded up a web server at the TCP level with RESTful routing. Now you could use that, but I would go with what the guys at Google coded, the guys and gals at Google, which is the HTTP listen and serve, right? Because that's what we saw when we started out. In this first example, we saw HTTP listen and serve, and then we went to listen and serve, and we say, oh, you know what? Net listen, TCP, and an address. Cool, and we get a listener, and then we call serve, and serve takes that listener in. We defer the close of that listener, and then we come down here and we accept for that eternal loop. We accept any connection coming in, and it's just the same stuff. Well, obviously, their code is a little bit more involved here, so it's more robust, but it's pretty cool to see what's happening at that underlying level. And if that interested you at all, if you were intrigued by that, come take my class in the spring. Server-side technologies, I think it's called, server-side programming, CIT 94, here at City College. Or if you aren't in the Fresno area, you could go to that Udemy deal. Whatever. How did I get that new incognito thing again? I just Shift Command N. I thought I just did that. There we go. Udemy, Todd McLeod. And very soon I'm going to have my web training up with Go. So, which is that repo, that code base I just showed you. It's going to walk you through that whole code base. So you can learn HTML and CSS. You can learn Go. And then you can learn web dev with Go. And you could walk out in 1 year. You nail that stuff. You could go to some place like Hack Reactor. You'd have to take Rio's JS stuff and add that in. But when you go to Hack Reactor, $104,000 salary, 98% graduate hiring rate. You'd go to Hack Reactor for 3 months. They put you through a code boot camp where 6 a.m. till 11 p.m. you code for 3 months. And you pay them $20,000 to do it. And they whip you and say, not good enough! Not good enough! Whoopsh, whoopsh, whoopsh. And then at the end, they give you a job. They put you in a job, and you get paid on average $104,000 in 1 year. That's a golden pathway. I've checked it out. I've been up there. I've met the people up there who run it. There's other boot camps like that, but they've got a really nice statistic that's easy to show right on their home page. And then you get to start building stuff, and then you meet other coders, and it's like totally cool culture and creative, and you like, basically code, and then go get drunk, and then sleep, and then wake up and code, and sleep, and wake up coffee, and then go to some crazy party that somebody's made a ton of money, like spent way too much money on, and then you code, and you go to sleep, and then you wake up in the middle of the night and you code, you drink coffee, and you pass out, and you wake up and you code, and you forget you haven't been exercising, so you get on the treadmill, and you listen to podcasts about coding, watch videos on coding while you run on the treadmill, and then you go to some crazy party. It's great. I'm not kidding, dude. Like my niece, what are you doing this weekend? I'm going to my friend's bar mitzvah. Oh yeah? That sounds like that'll be pretty nice. Yeah, I'm pretty excited. They're having, and then she said some famous rapper's name. I'm like, are you kidding me? I can't remember the rapper's name. It wasn't like Eminem. It's like on the next level down. And they're like, yeah, they hired him to come do the party. It's like, that's insane. How much did they spend? I don't know. They've got so much money. They wanted to hire Taylor Swift, but they figured that was a little bit too ludicrous. Yeah, I think that would be a little ludicrous. Hire Taylor Swift for a private party.
Was the rapper Lucas?
Maybe that was it. Maybe that's why ludicrous came to mind for me. But it was somebody, and she played the music for me. I'm like, have fun. All right, so that's a little bit about coding. I hope you enjoyed it.